Morning, everybody. Welcome back to Kuhn Studios here today. Today's Friday, January the 8th. Just a reminder that all assignments and work that is due for the second semester needs to be done today. So anybody watching this video who still wants to complete some missing assignments and improve their grade for the marking period, you have today to do that. So please take care of that quickly. Okay. As you can see behind me on the board, I hope you can see. I know that board is hard to see probably on the video, but the topic I'd like to talk about today is energy conversions. Right? As of today, we talked a good bit about how energy can change from one form to another. And as our first example of that, we used a simple pendulum. Okay? And we talked about how there's potential energy, which converts to kinetic energy, converts back to potential energy, and the pendulum swings back and forth. There's constantly a conversion of one form to another. However, we also talked about how the total amount of energy remains constant as long as there's no friction. Right? With friction, some of that energy gets bled off of the system. Okay, talked about that earlier in the week. The pendulum, the potential, and the kinetic energy thing. Yesterday's video, excuse me one second while I get this out of the way, I talked about other forms of energy. All right, all energy is either potential or kinetic, but energy comes in many different forms. And just to review some of those forms, I hope you can see this. We have electrical energy. Most of us are familiar with that. We are hooked up to the electrical grid, where this mysterious form of energy comes into our homes and is provided to us at the outlet. What is it? It is the movement of electrons through a conductive material. Usually when it's in our house, it's copper. And that allows us to do work. Right? We have figured out ways to turn electricity into basically whatever we want it to be. It can make our blender in our house work. It can make the dryer get hot. It can make our computer work. It can make our television work. It can make all sorts of different things happen depending on how we configure it. Okay, electrical energy. Next one on the list was thermal energy, right? Fancy word for heat. And once again, remember that heat and thermal activity is derived from the atoms in a substance moving. It's really the vibration or the movement of the atoms in a substance. Whoops. So that's thermal energy, heat. Third one on the list is light or radiant energy. Remember, light is the stuff we see, right? It is the rays that come out and travel through space. It carries energy with it, right? Again, light is the form of that we see, visible light, but remember we also mentioned that there are also a lot of different kinds of non-visible forms of radiation. X-rays, gamma rays, ultraviolet radiation, you name it. It's just human eyes are able to see the visible portion of light, but there's more of it that's out there that we can't see. Okay, so light or radiant energy. Sound. Okay, my vocal cords right now vibrate and send a wave out through the air molecules in the room. That is a form of energy. Mechanical energy. Anything moving. All right, my arms right now are mechanical energy, the energy of movement. The pendulum. We talk about its mechanical energy as it swings back and forth. Yes, it transfers from kinetic to potential, etc. But all of it is mechanical energy. Okay, and then finally, chemical energy. Certain substances, chemicals, contain energy inside the chemical bonds that make them up, and when chemical reactions break those bonds, sometimes that chemical energy, can be released. Okay? So those are the 6 basic forms. There are others. There's nuclear energy, which we didn't get into just because of time. And there might be some other ways to kind of look at and discuss energy, but those are 6 of the main categories. Okay. It's also a very important law pertaining to energy, right? And it's called the law of conservation of energy. And it states, energy does not get created or destroyed. Energy cannot be created or destroyed. Instead, it is transferred or transformed from one energy form to another. Okay. Energy cannot be created. What does that mean? Well, it means it doesn't just come out of nowhere. If there's energy present, then it came from somewhere else. Okay? And it doesn't get destroyed. Which means that if we use energy or do something with energy, the energy doesn't just disappear. It transfers to other forms of energy, right? So energy is constantly being transformed from one form to another. Okay, we're going to look at some examples of those energy transformations, because all around us we have devices that do that. How shall I start? I'm pretty sure you guys aren't going to be able to see this on the, looks like on my iPad screen. I hope you can even see this. I think that's one of my problems with these videos is the board behind me is difficult to see, but hopefully you can. Okay, so I have a bunch of stuff sitting here at my desk that is used to demonstrate energy conversion. So what we're going to do is kind of take a look at some of them and talk about how they convert energy, what the forms of energy are that are being converted. Let's start with the flashlight. I just had this out. Okay? Inside my flashlight I have a couple of batteries. Well, you know what? Maybe we should start with a battery if we're going to use that. This is a battery. Okay? Everybody probably knows that batteries produce electricity. How? Well, they produce electricity because of the chemicals that they contain. They usually have two cells, the positive side, the negative side of the battery contain two different kinds of chemicals. And the way those chemicals are set up, it creates energy. Right? So if I actually connect the two sides of the battery with a wire, creating a circuit, then energy is able to flow from one side to another, right, in the form of electricity. That's how a battery works. So what kind of an energy conversion is a battery? It is a conversion of chemical energy to electrical energy. Right? It changes chemical to electrical. Okay? Energy conversion. So let's think about that in a flashlight. So here I've got batteries. And if I turn the flashlight on, the battery takes the chemical energy, converts it to electrical energy, and then that electrical energy is used to create light energy. So I actually have three conversions here. Chemical to electrical to light. And of course, where's the light going? Well, the light's going out into the room and it's striking things. And it's actually probably going to create thermal energy. It's going to hit molecules and make them vibrate a little more quickly. Now, is it going to warm my room up very much? No. Right? But again, this energy doesn't just get destroyed, disappear. Okay, even though you might think that that flashlight is the end of the run here, so to speak. And just to show you, here's another fairly neat device. And I'm not sure how I'm going to move my. I don't know if I can. Hope you guys can see this here. This is called a radiometer. Let me see if I can get my iPad zoomed in a little bit. I'm going to have to adjust. Okay, it kind of looks like a light bulb, right? And I don't know if there's too much glare to see, but what it does is it has a little, boy, I don't know what you call that. It almost looks like a pinwheel, like the type of thing you would blow on, and it spins around in circles. One side's black, one side's white. right? Now we don't think of light as carrying much energy, but if I shine the light on that wheel in there, I'm not sure if you can see that, but that light starts to cause the wheel to spin, the little pinwheels. Okay, and the reason why that happens is a little more complicated than we want to get into here today, but here's the idea. Again, in energy conversion, now what do I see happening? Well, the chemical energy in the batteries is being changed to electrical energy, right, which is being changed to light energy, and now it's being converted into mechanical energy because that energy is now causing this radiometer to spin, right? So now we have a more complex series of energy conversions. So again, I know that's a little hard to say, but I hope you can make out what's going on there. Okay, let's do another one. Here's a candle, right? Energy conversion. If I light the candle and it burns, there is chemical energy in the wax, which is going to be drawn up through the wick and allows the fire to burn. So that chemical energy in this candle gets converted to light, gets converted to thermal energy. Of course, there's heat anytime you have a candle flame. So yeah, it gets converted to light and heat energy. Okay, another good example of chemical energy is right here. Right, this apple contains chemical energy, and if I eat it, take a bite, my body's going to digest it, and the energy contained in this apple eventually is going to let me, move around, make my heart beat, keep my lungs moving, drive all the things that allow me to be alive. So in that case, it could be, maybe they make my voice, talk. So it is the conversion of chemical energy to mechanical energy in the movement of human beings. Chemical energy to the conversion of sound energy when we talk. Chemical energy, of course, in here is also going to be converted to heat. Right? As warm-blooded creatures, we have to keep our body temperature up pretty close to 100 degrees. My room is only 65, 70 degrees. Outside is 30 degrees. So when I go out there, I have to take a considerable amount of chemical energy here and turn it into thermal energy to keep my body temperature up. Okay? How about this one? This is called a tuning fork. Okay, I can use mechanical energy and I can strike the tuning fork. Let me get the radiometer out of the way here. And I think you can probably hear that. The mechanical energy causes the tuning forks to vibrate, and then that vibration creates sound energy, which travels out through the air. Okay? So this is mechanical to sound. I hope you can hear that. Okay, another very important energy conversion that people have figured out how to use is something called generation, electrical generation. You've heard of generators probably before, right? One of the greatest devices that humans have ever come up with, and that's why we have electrical outlets in our house and things like that, is because of the discovery of this principle. This is an energy conversion that takes mechanical motion, okay, and turns it into electricity. How does that work? Well, it's hard to see here, but inside this little hand generator, there is a coil of wire. It's almost like a ball. It looks like, like a ball of yarn, but it's made of copper wire. It's a big coil. And a ways back, scientists discovered that if you take a coil of wire, tightly coiled wire, and you spin it and you place it inside a bunch of magnets, right? So as it's spinning around inside the magnets. Then in the wire, electrons start to move. and electrical current starts to be formed. Right? And in this particular kind, you can see that my mechanical energy is being changed to electrical energy, which is running this little light bulb right here. Okay? Mechanical to electrical to light, hand generated. Now, this is a very important process. This is used in all of our power plants. The reason why we have electricity in our house is because somewhere a big generator is turning. Okay? And you might have heard of coal-burning power plants, nuclear power plants, hydroelectric, where dams are formed and water is rushing down, windmills. All of those are different fuels, different methods used to do the same thing. They're all doing this, right? They're all running generators. So when I burn coal, the reason why I burn coal is to create steam. The steam goes through a big pipe and it turns what's called a turbine, which is like this big wheel that spins and it turns the generator. Nuclear power plants do the same thing. The only thing is they use a nuclear reaction to create the heat to make the steam to turn the generator. Okay? Hydroelectric, water rushes through a dam. What's it rushing through the dam for? Because it's spinning like a water wheel, turbine. And that's hooked up to huge generators, and all that power of that water is able to create massive amounts of electricity. Obviously with a windmill we can see it too, right? When that windmill spins in the wind, it's spinning a generator. And that goes out into the electrical grid, and that's how we produce all this electricity. Okay, very important to understand that for understanding kind of society. So here's a little setup where I have some devices hooked up. Now here's a generator. Okay, now I have a series of switches here on my board that I can open and close. I have electric wires that go around, and the circuits can be opened, right, when I take this little lever, and then closed when I put it down. And what it is it's a little metal bar that allows electrons to move through that particular switch and completes a certain circuit. So right now, the only one that I have closed is the one that runs the fan here, right? So as I spin my electrical generator, which is what this is, it's creating electricity because I have a ball of wire hooked up to going around a bunch of magnets, and that's creating electricity. The electricity is running through the wire, and then the electricity here with another electric motor is being converted to mechanical energy. So here's a crazy conversion, right? I start with mechanical energy over here, I change it to electrical energy here, and then the electrical energy is converted back to mechanical energy over here. Right? When I run a fan in my house, that's what I'm doing. Same conversion. All right, let's close another switch and see what happens. Okay. There goes my light bulb. I don't know if you can see that. And I got to really crank hard to try to get it to go, right? But if I create enough electricity, I can take my mechanical energy. Let me turn the fan off, actually. Maybe it'll work better. I'm not using my energy to make the fan spin because I opened the fan circuit. But mechanical energy is converted to electrical energy by the generator, goes over here to the light bulb, and is converted to light and heat. Okay, thermal energy as well. All right, and let's look at the last one here. Okay, so I have a bell on that. Mechanical energy to electrical energy, and the electrical energy gets converted back to mechanical energy, which is this little striker which is hitting these metal things. And then that's going to sound, right? So mechanical, electrical, mechanical, sound. All right, and if maybe I can close them all and get everything to go at once, but I'll tell you what, I'm probably going to have to work pretty hard here to get everything to go. Get the light bulb going a little bit. I don't think my fan wants to go. I'll tell you what, it's a lot of work to even generate that little bit amount of electricity. So to think about the amount of generation that needs to take place to run all the stuff our society runs, it's massive, right? It's going to tire me out trying to make a bell ring just with my arm, right? Okay. Here's the only one I forgot to talk about. I probably should have done this earlier, but in our homes we have all kinds of devices like this, right? Energy conversion. So, if you can tell, it is a corded electrical device. So it's plugged in. So it's taking electrical energy and converting it to thermal energy. It's got a little heater in it that makes the air hot. It's also got a fan, right? So that's mechanical energy. And it makes noise, right? So sound energy. So a hair dryer converts electrical energy to mechanical energy, to sound energy, and to thermal energy. Right? Look around your house, see if you can think about some devices that you have around that do the same thing. Okay, hold on, I want to zoom this iPad out just a little bit. Talk about one more thing and we'll call it a day here. Okay, so for today, what I'd like to have you guys do is I'm going to be posting a FetLab. Okay? And it should look like, I think I had it open, didn't I? It's going to be entitled Energy Forms and Changes. Okay, this is a fact. And you're going to go into the one here called Systems. And what you're going to get is some ability to change devices and figure out some conversions. Let me see if I can get the... See if it darkens up a little bit. Maybe you can see that better now. But this is kind of what it's like, what the FetLab looks like. And you can take different devices. You see the bicycle, the girl's bicycle is hooked up to a generator, and the generator is hooked up to water with a heater, etc. And it allows you to kind of play with some of those things and set up some energy conversions and to look at them. Okay, so that's that for today. Topic of energy conversions. The FetLab will be up for you to look at. Hope everybody has a good day.